Good evening, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. And in this series of 50 most important questions, most expected questions from vector calculus, we are into lecture number 3. So this is part 3 of this series. So 50 most expected questions, vector calculus, part 3. So may I know who all are present in this session? So good evening all, a warm welcome to all of you. We'll start the session. I'll share some information regarding me. I'm Ankit Joshi. I have been teaching in this GATE and ESC domain for more than 15 years. And yes, my subjects of interest are engineering mathematics, analog circuits, and signals and systems. Am I audible? So we are very happy and glad to inform that Gradeup has completed 5 years since launch, and this is the 5th anniversary of Gradeup. And on its 5th anniversary, we have brought some discounts, a kind of sale for our students, that for 24 months subscription you can get the course in 14,400. See, a lot of discount is available here. Similar is the case with 12 months subscription and 3 months subscription. A lot of discount is available here. You can enjoy the discount and you can join the courses going through on Gradeup platform. So this is regarding the you can see the screen. You can see gear up batch, rank up batch, and vision batches. These are the batches currently going on Gradeup platform. And you can contact at the number given below for any other queries further related to this. So these are the faculties dealing with different courses on ECE. And yes, this is something regarding to Gradeup green card subscription. These are the various features. You can have a screenshot and you can also contact at the number given below. See it. If the vector function is irrotational, then the values of k1, k2 and k3. So this is also a common variety that is available in vector calculus, that they will give you a vector function and say that this vector function is irrotational field and find out the values of k1, k2 and k3. So what you can do here, irrotational field means its curl will be 0. You can find out the curl and equate it to 0. Once you equate it to 0, you will be getting coefficients, the values of k1, k2 and k3. So what you have to do, you have to find out the curl of this vector function. How can you find out curl? In the first row you have to write ijk. In the second row it is del by del x, del by del y and del by del z. In the third row you have to substitute the coefficients, components. So x component is 3y minus k1z, y component is k2x minus 2z, and z component is minus k3y plus z. So on solving this determinant, you can equate it to 0 and you will be getting the values of k1, k2 and k3. So this I am leaving up to you. This is simplest question. Now, the magnitude of the directional derivative of this function f is given. X square plus 3y square in the direction normal to the circle. In the direction normal to the circle. Okay, so this is the circle. Perpendicular to this is your d vector, and you have to calculate the directional derivative of f. So you have to calculate del f, that is gradient of f, I del f by del x, j del f by del y, and now you can substitute the point. Point is 1, 1. ये point रख दीजिए यहाँ पर, substitute the point. So twice I plus 6j. This is del f. Now, in a direction normal to the circle, okay, they have given you a circle which is your d vector. So d vector is x square plus y square minus 2. This is not d vector. Surface is given. One more surface is given. Let us say the surface is 5. X square plus y square minus 2. And when you take its gradient, this will be your d vector. Normal to the surface, that is 2xy plus 2yj. And the desired point is 1, 1. So this is 2y plus 2j. So what will be d cap? So divide by the magnitude. So 4 plus 4 will be 8, 2 root 2. So I plus j upon root 2. This is d vector. And this is your del f. So directional derivative will be del f dot d cap. So 2 into 1, 6 into 1 upon root 2. This will be 2 root 2. 8 upon root 2 will be 2 root 2. So 2 root 2. Sorry, something wrong. That should be 4 root 2 beta. Yeah, 4 root 2. Option A is the correct answer. Next. See, directional derivative of phi at the point 1, 3, 2 becomes maximum in the direction of. We know that directional derivative becomes maximum in the direction of del phi itself. Okay, so you just find out del phi. I del phi by del x, that is 2y, plus j del phi by del y. So 2x minus 2y. Z component will be 0. Point is given as 1, 3, 2. Six I plus j. 2x minus 2y. 2 minus 6. I think some answers are missing. 6i plus 2x minus 2y. 2x minus 2y. 2 minus 6. That will be minus 4. So yes, some options are wrong. So there should be some z term also. So anyways, you know the procedure. You just follow the concept that directional derivative will be maximum in the direction of del phi, gradient phi. We'll move to the next. For the spherical surface, x square plus y square plus z square equal to 1. Okay, surface is given. So bring all the terms to the left hand side. सारी terms को left hand side पर ले आइए. लाओ. Bring all the terms to the left hand side. Now, unit outward normal vector. Okay, so what you have to do? You have to calculate gradient. That will be giving you normal vector. 2xi, 2yj, 2zk. Now, what is the point? 1 by root 2. Okay, sir. 1 by root 2 is the point. So 2 by root 2. Again 1 by root 2. So 2 by root 2. And z component is 0. So that will be vanished. So root 2 will be remaining. Root 2 is common. I plus j. But we need unit vector. So magnitude will be 2 plus 2 under root. That will be 2. So it should be divided by 2. So unit normal vector will be del phi divided by the magnitude. So when you divide this by 2, you will be getting I by root 2 plus j by root 2. Which option? Option A. Yes, just this class is started at 9 only. Next. See here. We have an important property that A cross B cross C is A dot C into B minus A dot B into C. A cross B cross C. This is A dot C into B minus A dot B into C. Now I need del cross P. So del dot P further operated by del. So further operated by del. So that operator is better to write on the left side, not on the right side. So this operator should be written on the right side. So del dot P, and this operator is written outside here on the left side, minus A dot B. A dot B means del dot del. Del dot L multiplied by C. C is our P. So del dot P and two same vectors dot product is their magnitudes is square. So del square P. Yeah. So option D is the answer for this. This is a property, standard property. Now here they are talking about Green's theorem. What do you mean by Green's theorem? Okay, चलो देखते हैं. See here. Suppose we have a closed curve I have to calculate. We have a closed region. We have a closed curve C. If we have a closed curve C which encloses a region R, this is region R enclosed by the closed curve C. And in this region there are two functions m and n defined. Here m and n they are the functions of x and y. So closed loop integral of m dx plus n dy by Green's theorem, this can be written as region based double integral del n by del x minus del m by del y dx dy. This is the statement for Green's theorem. This is Green's theorem. Now see here, integration of x plus y dx and x square dy. So I can say that m equal to x plus y and n equal to x square. M equal to x plus y and n equal to x square. M dx plus n dy. Now find out del m by del y. That will be 1. Find out del n by del x. That will be 2x. Now this integration m dx plus n dy over the closed curve C, this will be double integration over the region R del n by del x minus del m by del y dx dy, and this is equal to double integration over the region R, and the difference of these two partial derivatives will be 2x minus 1. Request all of you to hit the like button. So 2x minus 1 dx dy. Now what is the region of integration? So they have given you 3 vertices of triangle ABC. Say triangle is ABC, which is on xy plane. 0, 0, 2, 0 and 2, 4. Let us say this is O, A and B. Okay. So you can shade this region. In this region you have to integrate this. So let us integrate first with respect to y. So we will be drawing a strip PQ parallel to y axis. So limits of y, y1 will be 0. Let us integrate first with respect to y and then with respect to x. So this 2x minus 1 will come out. Now lower limit can be obtained from point P. Point P lies on x-axis, y is 0. Upper limit will be from point Q. Point Q will be lying on this line OB. Equation of line OB. Line is passing through origin. So y equal to mx. C will be 0. So slope will be perpendicular upon base 4 by 2, that is 2. So that is y2 equal to 2x. Now slide it from left extreme to right extreme. O to AB. So at point O, x coordinate is 0. On line AB, x coordinate is 2. So you can integrate this and get the answer of this integration. Integration of 1 with respect to y will be y. Upper limit minus lower limit, you will get 2x. Now dx. Now this integration is as good as the 12th standard integration, simple integration. So you have got two terms in the integration, 4x square. Integration will be 4x cubed by 3 minus 2x. Integration will be minus 2x square by 2, that is x square only. Limits are 0 to 2. So apply the limit. When you put upper limit 2, 8 4s are 32, 32 by 3 minus 4. So 20 by 3 should be my answer. So this question we solved using Green's theorem. Next, Let us say this right hand side is 4. So m dx plus n dy. What is m? M is 2x minus y and n is x plus 3y. So del m by del y minus 1. Del n by del x will be 1. Now their difference del n by del x minus del m by del y. So 1 minus of minus 1, that will be 2. So this integration, this is equal to double integration over the region R. Difference of the partial derivatives, that is 2 dx dy. Correct? So this region R is the area under this ellipse. So this ellipse what is its x-intercept? X square by 4 and y square by 1 equal to 1. So 2 and this point is 0, 1. So what is the area of this ellipse? Pi AB, pi into 2 into 1. So already 2 is outside, pi into 2 into 1. So we can say that 4 pi will be the answer. So without doing much effort, we can calculate, because ultimately it was 2 times area of the ellipse. So area of ellipse is pi AB, where A is 2 and B is 1. See this question. Integration of x minus y dx plus x plus y dy. We have to find out this. So this will be double integration over the region R, del n by del x minus del m by del y. Double integration over the region R, del n by del x. This is your n. And this is your m. Del n by del x will be 1. And yes, del m by del y will be minus 1. So 1 plus 1, 2. So this is double integration over the region R. 2 is out, dx dy. So this is area of the region R. Now what is region R? Region R is the region enclosed between these two parabolas, y equal to x square and x equal to y square. So of course this point will be 1, 1 and this point will be 0, 0. So we want to calculate the area of this common portion. So we will be drawing a strip. So PQ, obviously we can say that y1 and y2 and then x1 and x2. What is y1? Y1 will be obtained from this parabola x square and y2 from this parabola, that is root x. Now x1, x2, 0 to 1. dy and then dx. 2 is out, 0 to 1. Integration of 1 will be y, root x minus x square dx. So integration of root x, x to the power 1 by 2 will be x to the power 3 by 2 upon 3 by 2, that is 2 by 3 minus x cube by 3. limits are 0 to 1. So when you put upper limit 1, what will you get? 2 is already out. 2 by 3 minus 1 by 3, that is 1 by 3. Lower limit will be 0. Answer will be 2 by 3, 0.67 should be your answer. Can I have your response? Requesting all of you to hit the like button, share this link among your friends. Green's theorem, the most important topic in vector calculus. So value of m is x square plus xy, this one, and value of n is y square plus xy. So del m by del y and del n by del x, that we have to find. Del m by del y, that is x, and del n by del x is only y. So del n by del x minus del m by del y, this will be y minus x. So answer for this integration f dot dr will be double integration over the region R y minus x dx dy. Now what is this region R? 0 to 2 and 2 to 0. 0 comma 2 to 2 comma 0. This is the point. Just find out the limits, consider this as the region, find out the limits and integrate this. This is up to you. Vivek Nanda Raut, Ravish, Shivani, Saugat. Now see this one. F of r dot dr. F of r is given, which is okay, along C, which is a straight line joining 0 0 to 1 1. Okay, great. This is x-axis and this is y-axis. So now what you have? F dot dr. F vector is x square I plus y square j and dr is xi plus yj. So this is x square dx, y square dy. Okay. So closed loop integral f dot dr, this will be double integration over the region R, del n by del x minus del m by del y dx dy. So del n by del x, this is n. Del n by del x will be 0 and del m by del y is also 0. So what you are getting? 0 should be the answer. Now this is a function in which this is a line integral in which you are moving from origin to the point, and the points are mentioned in three-dimensional space. O, coordinates of O are 0, 0, 0, and coordinates of A, let they are 1, 1, 1. So OA, can we have the equation of line OA? X minus 0 upon 1 minus 0, y minus 0 upon 1 minus 0, and z minus 0 upon 1 minus 0. So you can have line as x by 1, y by 1, and z by 1. Let us say this is equal to k. So obviously you will get x equal to k, y equal to k, and z equal to k. So dx will be dk, dy will be dk, and dz will be dk. This line integral, 2xy square dx plus 2x square y dy plus dz, this can be converted in terms of k, that is in terms of this parameter k. Yes sir. So you are moving from O to A. 2, x is nothing but k, y is also k, so 2k cube dk. Again 2k square into k, 2k cube dk, and dz is dk. So O to A, so we want the limits of k will be from 0 to 1, 4k cube plus 1, dk is common. Integrate this, 4 out, k raised to 4 upon 4, integration of 1 will be k, limits are 0 to 1. So 4, 4 cancel, when you put the limit k, you will be getting 1 plus 1, 2, minus 0, answer will be 2. So when you are integrating from 0, 0, 0 to 1, 1, 1, your original limit was O, and your source point was O, and destination point was 1, 1, 1. But when you converted the integral in the form of parameter, always for the first point k will be 0, and for the second point k will be 1. Always, this will be always true. See it. Here we have to move from 0, 0, 0 to 1, 1, 1, but they have already mentioned the conversion rule. So conversion rule, that is the parametric, how we have to do the parameterization, that is mentioned in the problem. So in place of x you have to put t, in place of y you have to put t square, and in place of z you have to put again t. So f dot dr, this is 5xz dx, then 3x square dy, sorry, 3x square plus 2y, just one, I'll write here, f dot dr, 5xz dx, then y component 3x square plus 2y multiplied by dy, and z component x square z multiplied by dz. Now see here, x is given as t, y is t square, and z is t. So dx will be dt, dy will be twice t dt, and dz will be again dt. So you have to put all this substitution. You have to put all this substitution in this equation. So f dot dr will be 5xz, 5xz. So 5. What is x? X is t. Z is t. So t square. What is dx? Dx is dt. 3 x square, that is t square. 2y, 2t square. Dy, twice t dt. X square z dz, x square, t square. Z is t, so t cube. Dz is dt. So now you can take dt common. 5t square. Then again 5t square. Okay. 5t square. Then 5t square into 2t, that will be 10t cube plus t cube. So this will be 5t square plus 10t raised to 4 dt. So you have to integrate this f dot dr from 0, 0, 0 to 1, 1, 1. So integration of f dot dr from 0, 0, 0 to 1, 1, 1. This will be integration of 5t square plus 10t raised to 4 . This is 10t cube. 10t cube dt. And the parametric values will be, limits will be t equal to 0 to t equal to 1. So 5t cube by 3, 10t raised to 4 by 4, and put the limits 0 to 1. So 5 by 3 plus 10 by 4, that is 5 by 2. 6 will be the LCM. 25 by 6 will be the answer. Lower limit will be 0. Now see here. They have given us a vector f. We have to find f dot dr. F dot dr. So twice z dx (11t cube). Yes, 11t cube, 11t cube, 11t cube, and correction, small correction is there. Fine. So 11t raised to 4 upon 4. So answer will be changed. So that will be 5 by 3 plus 11 by 4. Fine. 12 will be the LCM. Check it once. Gaurav, Sushrut. Yes. So twice z dx I want f dot dr. So twice z dx plus twice y dy and twice x dz. This is f dot dr. So our line is 0 to 1, 4, 1 minus 1. 0 to 1, 4, 1 minus 1. Let us say this is A, this is B. Equation of line AB. AB. So x minus 0 upon 4 minus 0. Y minus 2 upon 1 minus 2, that is minus 1. Z minus 1 upon minus 2. This is equal to k. So x will be 4k, y will be minus k plus 2, and z will be minus 2k plus 1. X will be 4k, y will be minus k plus 2, and z will be minus 2k plus 1. So dx will be 4dk, dy will be minus dk, and dz will be minus 2dk. So you have to replace this in terms of k. So twice z. What is z? Z is minus 2k plus 1. Dx is 4dk. Twice y is minus k plus 2 dy. Twice x, dz. X is 4k. dz is minus 2 dk. Mukul Parikh. Timing is 9 p.m. Saturday and Sunday. So 8 into minus 2k, minus 8. 4 2s are 8, 8 into 2 minus 16k, 8 into 1, that will be 8. dk is out. Minus 2 into minus k plus 2k, minus 2 into 2, that will be minus 4. dk is out. Minus 2 into 2 minus 4 into 4, minus 16k. Let's check once. So now we want to integrate this. Just simplify this first. So 8 minus 4, that will be 4. Minus 16 minus 32 plus 2k, that will be minus 30k. Himanshu Sharma, best book, depending on your branch, syllabus is little bit different branch wise. Okay, so meanwhile all of you calculate this integration. You have to put k equal to 0 to 1. Limits will be k equal to 0 to 1. What you can do? You can use either BS Grewal or Krzyk, and if you are well versed in the basics, then you can go for the Thomas calculus also. These are the best books. So there are many others also. So see, again I am saying, depending on the topic you have to opt for the books. So if you go for the linear algebra topics, it's well and good that you should go for BS Grewal is the basic level book. You can go with this book. You can just follow the concept from this book. HK Das is also good. That is not a book, it's a guide. Coaching, any coaching material is just for the refreshments of the refreshing your concepts. Okay, if you are in second year and if you want to learn something, you should go buy some reference books, textbooks. Now this is related with the divergence theorem. What is divergence theorem? That if you have a surface integral, closed surface integral A dot ds, this will be equal to volume integral divergence of vector into dv. So divergence theorem converts a surface integral into a volume integral. Closed surface integral is converted into a volume integral. Now here r vector is given, so r dot n cap ds, r vector dot n cap ds, you are calculating the surface integral over this, so this will be equal to volume integral divergence of r vector into dv. And as you all know that in our previous class we derived divergence of r vector is 3, so 3 will be taken out. Volume integral of 1 will be nothing but the volume of the volume enclosed by the closed surface. So here surface S is bounding a volume V. It means surface S is enclosing the volume V. So answer should be 3 times V. This integration will result in V only. On solving this integration, you will be getting this volume V. 3V will be the answer. See, consider a closed surface S surrounding a volume V. If R vector is the position vector of a point inside S, okay, with n vector is the unit normal, okay, the value of the integral, closed surface integral 5 times r dot n cap ds. So closed surface integral 5 times r vector dot n cap ds. By divergence theorem, this is equal to volume integral divergence of, see, 5 is constant taken out, divergence of r vector dv. Divergence of r vector is 3, so 5 3s are 15, and the volume integral dv. So volume integral of 1 will be nothing but the volume enclosed. So volume enclosed is given as v, so 15v will be my answer. So these are the hot varieties of questions appearing in GATE exam regarding the divergence theorem. Okay, so tomorrow also you will be having a session around 9 p.m. 9 to 10 p.m. will be the class timings for tomorrow's session. And in tomorrow's session we will be learning surface integrals, how to calculate surface integrals, and we will be observing some applications of Stokes theorem, that is how to deal with Stokes theorem. Surface integral and Stokes theorem will be tomorrow's agenda, 9 p.m. Remember the time. Do like the session, share the link, and subscribe our channel. Thanks a lot. We'll meet tomorrow.